Hello everyone, for First Updates Now, I'm Tyler Olds, and you're watching Behind the Bot. It's a fun show where we dive deeper into FTC robots and what makes them work. And today I'm here with FTC 15317 Air Code 404 from Harrisonburg, Virginia. This team has won the Collins Aerospace Innovative Award at all three of their competitions this year, and has a fantastic robot. And today joining us talking about this robot is going to be Narinjan, Thomas, Anish, and then joining virtually is Carlo.
Hello.
And we're going to be diving more into this robot, including some of the great features and functions, a really unique PTO with the Wobble Mechanism, some cool programming, including OpenCV, Vuforia, great intake, and of course, full system here on Behind the Bot.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting fun so we can continue to make content for you. Stryker makes some of the most revolutionary medical equipment and is a big supporter of FIRST and its participants. If you are looking for an internship or career that supports you being in FIRST, check out careers.stryker.com to learn more. If you're on an FRC or FTC team and you're currently meeting safely in person and have a functional robot, we'd love to have you on our Behind the Bots or Behind the Bumper segments. Go ahead and reach out to us on any of our social channels, on Discord, or send us an email at admin@firstupdatesnow.com, and let's get your team scheduled to be on First Updates Now. So Narinjan, start me off with the intake on this robot. Tell me a little bit about the iterations you've gone through as well. I know it's been working really well for you so far, so tell me about your journey to get there, and we'll kind of follow the entire ring path through your robot.
Yeah, sure. So most of our iteration happened in the beginning stages through prototyping, and those consisted of lots of wooden prototypes testing out lots of different variables. And our end result is this collector right here. It has 4 rollers at the top and 1 on the bottom, and including this front one that pivots up and down. And so at the beginning of the match, we release this front roller, and after that, we can just pick up rings off the floor with ease, which we should be able to demonstrate. And so they just get funneled down into our hopper.
One of the things I want to ask you on that I've seen that is maybe a little bit unique is that a lot of teams with the fold-out intakes, it's not as passive a lot of times for things, and it just looks like you have a couple straps. Can you walk me through the reason, or maybe some of the choices you made in regards to just having those couple straps hold it in, and then how does it actually release from there as well?
Yeah, sure. So we knew we only need to release it once in the beginning of the match. So we have it pivots, and there's a server up top that locks into place. And so at the beginning of the match, that will release. This will drop down, and these straps just hold it at the right height to properly intake.
Sure, makes a lot of sense. So, Thomas, you're going to be talking about the hopper next on the robot. We just saw the rings go right into there. Looks like a very smooth transition. So talk to me about how it gets from your intake into the hopper and then the hopper into the shooter as well.
Yeah, for sure. So we have this one roller here that's made out of these custom wooden circles that are just stacked right next to each other. And that wooden roller pushes them into this hopper situation that we have going on here. So this hopper is a bottom to up hopper. So when the rings go in, they settle all the way at the bottom, and they actually get pushed upwards. And then we have this 3.7 never rest motor that powers some of these wheels here, and these wheels actually push the rings out to the side where they contact the shooter wheel here.
So from other teams I've talked to as well, too, they've experimented a lot with the different types of almost like it's kind of like a magazine, right? Like the way that it works on there. Have you used that type of process before in previous years' games? Or if not, what kind of led you to the decision to go this route?
Yeah, so we haven't really done anything like this before. We really wanted to try this because it's a more like smoother pathway. It's a more efficient pathway than trying to raise your entire stack upwards just to move the bottom ring.
Sure.
Yeah, so that was our main point of going with this type of system.
So Narinjan, wrap up the ring cycle for us going into the shooter. I'd love to hear a lot about with the type of shooter you have, maybe some of the compression that goes into it, some of the RPMs and the speeds of it as well, and of course some of the iterations you've gone through.
Yeah, sure. So our shooter is a simple one wheel on the side and an arc on the other side, and it's a 4-inch wheel that's spinning at around 6,000 RPM because we have these motors which are actually geared down, but then they're geared back up on the bottom with use of pulleys. And so we have 2 motors powering the shooter. We got the compressions again through lots of prototypes. I think we have around a 1/4 inch of compression currently, but I could be wrong. and we feed them up and they take it to the shooter and we can shoot out. Another thing about our shooter is to help us get more shoot from more distances on the field. Our whole entire shooter and hopper system actually pivots up and down, which we can demonstrate again. And so that's the physical capability, and we can even shoot a couple out right now if you'd like to.
Sure. So a couple of questions to ask on that as a follow-up as it goes through. First of all, is that a compliant wheel that's being used as your flywheel?
It is a compliant wheel. We knew that we shouldn't spin up the green or blue wheels too fast, but we found the black wheels did not expand too much, and they were shooting pretty well for us. So we just continued to use those.
So my question with that, with the compliant wheels in particular, is like there's obviously a lot of give to it, right? The wheel itself is going to compress a lot, but on the other hand too, as it spins faster, the wheel expands. So how long did it take you to kind of get that the way that you actually shot to kind of be as accurate as possible?
Accuracy-wise, we just made sure to construct a robust system at the end. We spent a lot of time prototyping with less robust systems to figure out the variability in other parts of the shooter, but to make it precise at the end, we just made it a very stiff robot that so this arc doesn't give it all, and so that we try to keep other things constant.
Sure. And then the other thing to ask with the shooter as well too is how many different pre-programmed positions do you actually have? I know we'll be talking about coding a little bit later, but you said you can get more distances and shots. Do you typically have like a couple different set areas you shoot from?
We have a couple areas we shoot from, but we can shoot from pretty much anywhere in the field that we can see the euphoria target. So infinite number of possibilities.
Okay, so you're using the targeting is actually adjusting the angle. Is that correct?
It adjusts the angle and the speed of the shooter.
Okay, and then we'll get a little bit more into that as well too with what you're using for Vuforia. But before we do that, let's head back over to Thomas, who's going to be talking about your Wobble mechanism and how it works, and then some of the iterations that go into it. Thomas.
Yeah, so I'll just walk over around here. So this is our Wobble mechanism here. Because we went with 2 motors on the shooter, we actually didn't have a motor to power our Wobble mechanism. Sure. So what we did here was actually pretty unique. We custom designed our own, what we like to call the PTO. And essentially, it's just this one shifting gear that can move downwards and upwards. And when it's in the upwards position, it's engaged into just the stop. So the lift doesn't move. But when it's engaged downwards, it's actually engaged into the collector, one of the axles of the collector. And so we can power a pulley using the one of the axles of the collector just by the shifting gear. So if we want to demonstrate this really quick, this shifts down ever so slightly, engaging with this bottom gear, and then that will actuate a pulley that lifts our lift. Our stringing of our lift is also pretty unique. We wanted to save space to stay within inside the 18. So with actually one pull of a string, our Wobble mechanism actually comes outward, and then it also goes upwards in the same motion. And that's just done by having a little piece of rubber that pulls it upwards, and then the string is attached to an outside pivot. So this can pivot outwards and then upwards with the same motion. And if you want to demonstrate that going up. Yep. So it just goes up like that. And then with our claw, this is a fully customly designed. We went through a few different prototypes to come up with this design. So it's a single servo that moves 2 arms using some gears that we laser cut. And it perfectly grabs the wobble goal and allows us to lift it up and manipulate it during the game however we want.
So Thomas, something to ask you on the wobble goal mechanism is how much like degrees of air do you have? Because when you have 2 claws coming together, the wobble goal is obviously, it's called a wobble goal, right? It's very tippy. So can that wobble goal potentially tip underneath your claws as trying to grab it? Like I'm thinking like a carnival machine here almost.
Yeah, so we've had a little bit of issues with that, with moving forwards and backwards. It comes down a little bit to driver practice, making sure to have really smooth controlled movements. We've done a few things, such as this claw, this little pointy piece here, to try to make sure that the claw really grasps on. Also, some fine-tuning with the servo positions also allow it to fully grasp the wobble goal.
And then for your PTO, which drive motors is that actually connected to, did you say?
This is connected to the collector motor.
Okay, yeah, very cool. So, you know, we've seen PTOs a lot in FRC, and we've started to see them more in FTC, but usually more for climbers. I think this might be the first time I've seen on a wobble mechanism before. So I love the concept of that idea, especially not connecting it to your drive, actually, so you can still drive around and pick it up at the same time. So really cool to hear about that. Thanks for telling us more about that. So we're going to move it over to Anish, who's going to be talking about some of the coding, including the auto aim feature, and then Carla will be joining in to talk about some more of the autonomous Vuforia, OpenCV, that sort of thing.
Yeah, thank you. So basically what we have with this robot is an auto aim feature with which, like, with a press of the button, the drivers can move the robot to turn facing towards the goal, and also adjust the angle of the shooter and the speed of the shooter to make it have the best chance of going into the goal. And how we do that is we use this Vuforia camera we use this web camera on the back, and we run Vuforia with that. So that gives us the X and Y coordinates of our robot on the field based on the images around the field. And then using those images, we know the orientation of our robot. So that tells us how much we need to turn in order to face the goal. And also it tells us our distance from the goal. And that's important because we ran a bunch of testing telling us the proper angle and speed of our shooter so that we can get it into the goal from a certain distance. And that's how we use it to adjust the angle and speed of the shooter.
Yeah, I really like that it's connected to both. You know, in FRC, we have the limelight is a very common thing to do something like that. It's great to see in FTC that that's starting to become more and more common of having great ways to do that. So what would you say like your accuracy is typically when shooting with this?
I would say our accuracy, it's not, obviously it's not completely foolproof. We have good days and bad days.
Sure.
I would say that we've definitely had times where it's been really smooth and we've been really happy with it. And obviously there have been times within the season where we've had to reevaluate it and add some adjustments into the formulas we use in order to provide a better result.
Yeah, makes a lot of sense. So, so Carla, if you want to jump in at any time as well, Carla's joining us remote to talk about a little bit more in regards to your autonomous, your structure code, that sort of thing. We'd love to hear more about what goes into the guts of the robot there.
Yeah, I think Anish explained it pretty well. We focused a lot this year on making our programs as autonomous as possible, especially for things like power shots during the driver control period. We made it so that by pressing a button, if the drivers are within range of a Vuforia target, they're able to shoot all 3 power shots autonomously. And that basically injects autonomous code into the driver control teleop. So that's really neat, I think.
Yeah. Are there any other sensors on the robot? Maybe the highlight they use as well too during the match?
Yeah, I can do that for you. So we have one sensor here that's for Vuforia, which I mentioned before. We also have another web camera right here. We use an OpenCV tool, and that allows us to identify the number of rings that are in the starting stack at the beginning of the game. And in addition, for our use during autonomous, we have it. You might have noticed here that a touch sensor here on the arc of the shooter, so that every time a ring passes through, it touches the touch sensor, and that tells us during autonomous whether our rings have successfully shot or not.
Well, that's really cool. I mean, what a fantastic machine this is. Love hearing about just some of the cool, unique features. So thank you so much. Once again, this is 15317, air code 404 from Harrisonburg, Virginia. Good luck, of course, the rest of the way through this season. But then in future seasons, looking for big things out of this team and can't wait to see what your team is able to bring to the table. Thanks for taking the time, guys.
Thank you so much.
We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FIRST alumni to join their internship program, and FIRST mentors who are looking for a great career with a company who actually supports their FIRST journey. Go to careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow. And check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.